Every single thing you've ever seen has a cause. Rain falls because water condenses in the atmosphere. A tree grows because a seed was planted years earlier. Even stars are born when enormous clouds of gas collapse under their own gravity. Cause and effect seem to be built into reality itself. So when people say the universe came from nothing, it immediately raises another question. How, if there was truly nothing, what could have started everything? It's one of those questions that sounds simple at first, but the moment you begin thinking about it, it becomes incredibly difficult to answer. Because before we can ask where the universe came from, we first have to ask something much simpler. What exactly is nothing? Most of us picture nothing as an empty black space. No stars, planets, think endless darkness. But see, that's still something. There's still space. It could still point in a direction. Time would still be passing. Physics doesn't consider that to be nothing. Absolute nothing would mean no space, no time, no matter, no energy, no quantum fields, and no physical laws. Not an empty universe. No universe at all. And that's where this mystery takes an unexpected turn. Because if there was no time, what does it even mean to ask what happened before the universe? Before is a measure of time. Without time, the question itself may not make sense. It's a little like asking what's north of the North Pole. The words form a sentence, but they may not describe something that can actually exist. This idea comes directly from modern cosmology. When scientists rewind the history of the universe, galaxies move closer together. Temperatures rise, everything becomes denser. Keep going far enough, and eventually our equations stop working. People often imagine the Big Bang as a giant explosion that happened in empty space, but that's not what the Big Bang theory says. The Big Bang describes a time when the entire observable universe was already extremely hot, incredibly dense and expanding. It doesn't tell us what caused it or what came before it, and it certainly doesn't claim that scientists have solved the mystery of why the universe exists. In fact, the earliest moment our current physics can describe is about 1 Planck time after the expansion began. That's roughly 10 to the power of -43 seconds. Earlier than that, general relativity and quantum mechanics no longer work together. We know our current theories are incomplete, and that's why physicists continue searching for a theory of quantum gravity. Until then, there's a limit to what science can confidently say. Even though we can't yet describe the universe's very first instant, observations do give us a remarkably clear picture of what happened almost immediately afterward. One of the leading ideas about the universe's earliest moments is cosmic inflation. It proposes that about 10 to the minus 36 to 10 to the minus 32 seconds after the Big Bang, the universe underwent an extremely rapid expansion, growing by an enormous factor in a tiny fraction of a second. Inflation wasn't matter flying through space, it was space itself expanding. This brief episode helps explain why the universe looks almost identical in every direction, why its overall geometry appears nearly flat, and how tiny quantum fluctuations were stretched to become the seeds of the galaxies and galaxy clusters we see today. While observations of the cosmic microwave background strongly support many predictions made by inflation, scientists still don't know what triggered inflation, what drove it, or whether inflation is the complete picture of the universe's beginning. Of course, that hasn't stopped scientists from proposing ideas. One of the most famous involves quantum mechanics. You probably heard that particles can appear from nothing. That's true, but only if we're careful with what nothing means. Empty space isn't actually empty. According to quantum field theory, every point in space is filled with quantum fields. Those fields constantly fluctuate, allowing tiny particle-antiparticle pairs to briefly appear and disappear. Experiments such as the Casimir effect provide evidence that these quantum fluctuations are real. Some physicists have suggested that an entire universe could begin through similar quantum processes. But notice what's already present. There are quantum fields, physical laws. There is a mathematical framework allowing those fluctuations to happen. That is an absolute nothing. It's a physical state. In 1973, physicist Edward Tryon proposed a bold idea. He suggested that our universe may be simply one of those things which happen from time to time. His argument was based on quantum mechanics and the possibility that the universe has zero total energy, where the positive energy of matter is exactly balanced by the negative energy of gravity. If that's true, then a universe could, in principle, emerge as a quantum fluctuation without violating the laws of physics. It was a revolutionary idea, but it didn't answer every question. Tryon's proposal still assumes that quantum laws already exist, meaning it doesn't explain how absolute nothing could produce a universe. More than 50 years later, his idea remains one of the early ideas that helped shape modern quantum cosmology, but it is still a hypothesis rather than an experimentally confirmed explanation. Another proposal comes from physicists James Hartley and Stephen Hawking. Their model suggests that near the beginning of the universe, time may have behaved more like another dimension of space. If that's correct, asking what happened before the Big Bang could be like asking where the edge of Earth's surface begins. There isn't necessarily a boundary. Alexander Vilenkin proposed another idea. He suggested the universe might have formed through quantum tunneling from a state with no classical space and time. There are also bouncing universe models where an earlier universe contracts before expanding again. And there are multiverse theories where our universe could be one of countless others. These ideas are actively studied. Some are mathematically elegant, none have been confirmed. That's an important distinction. In science, a good idea isn't accepted because it sounds convincing. It has to survive evidence. Right now, no experiment has shown which explanation, if any, is correct. So, did the universe come from nothing? The most accurate answer is we don't know. If space fascinates you, subscribe. I'll see you in the next one.